All right, section 5 is dealing with the measuring of segments. So when we have our segments, we can be able to give them some sort of a number amount. You know, it is 8 inches long, it is 12 feet long, it is 8 miles long. Okay, so we can give it some sort of measurement to help us describe it even more. And so let's talk about postulate 1.5. Okay, so postulate 1.5. Um, take a second, you can write this down. The points of a line can be put into one-to-one correspondence with the real numbers so that the distance between the two numbers is the absolute value of the difference of the corresponding numbers. Okay, so that sounds very long-worded for what you really are trying to do here, which basically what it means is that the distance between 2 points is the absolute value of the endpoints when they're subtracted to each other. Um, absolute value because it should always be positive when we're talking about these distances. And so we have um, basically a way that you can think about this is, let's say you want to measure something. All you have to do is take a ruler and you just put the ruler up next to the object. It doesn't have to be at 0. Wherever you start at and wherever you end at, you take those two numbers and subtract them. Take the absolute value of them and you end up with the answer. So if I have something and I want to measure it, and when I take a ruler and I put it up next to it, the first number I see is 3, the last number I see is 9. What I would do is I go 9 minus 3, and that gets me 6. If I go the other way, 3 minus 9, I get negative 6. But again, you want to take the absolute value, so you always want these to be positive. And that's basically what this is saying. Whenever we measure stuff, we usually put it at 0 because then we don't have to do that extra math. So that same object that goes from 3 to 9, I could move my ruler over and start at 0 and it end up at 6. And it's still the same thing. Okay, so that's what this is basically saying is whenever you're measuring something, you're giving the endpoints some sort of value, and then you're finding the difference of those values. Okay. All right, so congruent segments. So if you have two segments that are exactly the same length, they will always be congruent. Okay, and we're talking about line segments here. So the congruency sign is this little sign right here. It's a little equal sign with a little wave above it. Okay, that means congruent. And remember, congruent means something that is exactly the same. Okay, if I have two pens made from the exact same company, same color, same brand, everything like that, same model, those are congruent. They're exactly the same. Okay, so that means congruent. So congruent segments are basically line segments, which all line segments are essentially the same, are line segments that have the same measure. Okay, so as you see here, we have AB and CD. AB is equal to CD if we're saying that their length, their measure, is the same, which we can write it this way. AB is equal to CD. That's talking about the lengths of them. They're both 10 inches long. They're both 5 feet long. Okay, that's how you would write that one. Okay, because they are congruent, we would also say that the segments are, or because the lengths are the same, are equal, we would also say that the segments are congruent themselves. So we would say line segment AB is congruent to line segment CD. So when we're talking about congruency, you're actually talking about the shape itself and the object itself, not individual measurements. Okay, so the objects are the same. This line segment is the same as that line segment. Okay. All right, postulate 1.6. I'll give you a second so you can write this down. Okay, so if you have 3 points, A, B, C, and they're all collinear, meaning that they're all in the same line, and B is between A and C. So basically what you're saying is that if you have a line segment and you have 3 points, and then one of the points is in between them, obviously one of them will be. And we're saying specifically B is between them. Then we know that the segment AB, the length of it, plus the segment of BC will always equal the entire segment AC. So if you have a, let's just take a ruler. If you have a ruler or a piece of string and you cut it in the middle of it, just not in the exact middle, just somewhere in the middle of it, if you take that first segment lengths and you add it to the last segment's length, they will equal the entire thing. So if you have a ruler that's 12 inches, and if you cut it right in the, you cut it somewhere in there, the first half is 4 inches, the second half has to be 8 inches, because together they would create 12 inches. Okay, and that's what segment 1/6 is basically stating, is that if you have this situation and you add them together, they will always be equal. So let's throw in some algebra here, since we're doing geometry. Let's throw in some algebra. So we have line segment ABC. AB is 4x minus 20, and we also know that AB is 100. BC is 2x plus 30. So what I want you to do is take a second. I want you to find the value of x. Now, when you find the value of x, the easiest way to do this is to set it up and go 4x minus 20 is equal to 100. Okay, because we know segment AB is 100. And then from here you go through your algebra skills and you solve it. Move that 20 over and then divide by 4, getting you x is equal to 30. So x is equal to 30. X value. Okay, so now what's the length of BC? Length of BC would be taking that 30 and plugging it in for the x. So 2 times 30 plus 30. 2 times 30 is 60 plus 30 is 90. So that means segment BC would be 90, and the entire segment AC would end up being 190, because you would add up AB and BC. Right. That's the end of this section, section 5 of geometry.